Hello everybody, today we are going to explain to you how medical physics is applied to medical technology. If you're ready, let's get started.
There are two main topics that you will briefly learn for today. The first topic is the dynamics of blood circulation, and the second is Ohm's law applied to the blood flow. Let's move to the first topic then. Dynamics of blood circulation. It occurs when there is the difference in pressure, but if there is any difference in pressure, the blood cannot flow as well. And let's take a look at the expression. As you see, blood flow depends this which volume flow rate equals pressure gradient or pressure difference over resistance of the flow, and can change rate of the flow to another from that is pi times radius vessel diameter. Power 4/8 times blood viscosity and vessel length.
For the resistance on volume flow rate, suppose that the flow rate is 100 cubic centimeters per sec. And try to differently determine values of variables in the rate flow expression if we represent a double value into length and viscosity. The flow rate will decrease because it's an inversely proportional relationship. If we represent the value into pressure and radius, the flow rate will increase because it's definitely directly proportional each other. By the way, when you want to get a fast flow rate, just increase radius the most because it's powered by 4.
Effect of vessel diameter and blood flow on resistances we already mentioned in the flow rate expression. Once you increase radius, you'll see a dramatic increase in the amount of blood flowing through blood vessels. As a figure you see, the more radius, the more flow rate. Right now, moving on to the second topic sits about Ohm's law applied to blood flow. We applied knowledge of Ohm's law for electric circuit and for flow together. Then we can learn about blood flow, which is the total peripheral resistance, that is the sum of all vascular resistances within the circulatory system. Therefore, there are two types for arrangement in Ohm's law. The first is parallel circuit that comprises branches so that the current divides and only part of it flows through any branch as given figure. When looking at the expression, it greatly reduces the total resistance of capillaries. The second one is series circuit that comprises a path along which the whole current flows through. Each component as a given figures, and then considering the expression, it increases the total resistance of capillaries. And this is all some topics about medical physics applications in medical technology in brief for you. Finally, we are thankful to every listener